We are live. Welcome back. Yes. Congruency, chapter 2.2. Congruency. What is the definition of congruency? Same size, same length. Meaning, I can have a triangle. Really good. I can have a triangle, and I have the same triangle, and I just flipped it. I gave it another color and said, well, these two are congruent. Find the length of whatever. And that is the thing you have to find. So let's start. KLM, LM, and here they say it's PQR. Let's give this 7. 7, and I'll say this is 7. What else? 10. Oh, by chance, you know Pythagoras theorem?
I do.
Yes. Most of the time, they do stuff like this, and at the other side, doesn't have always, they do this as well. So you know in advance, this angle is the same as this angle. Or this specific triangle rotated a specific way, and now this specific angle is here. Yes? So you don't take, oh, M is here. No, M is R. Yes? So that's why they put either a dot, sometimes asterisk, it depends. And now, for example, they can say, all right, what is the length of QP? Looking at these two triangles, they say, okay, if MK or KM represents on the other triangle QR, what is the length of, well, let me see, PR? Which length on triangle A represents PR on triangle B? Sorry? Yes, as in ML represents which side, yeah? PR, correct. That's it. That's all there is to it. Chapter 2.2. We've just done chapter 2.2. That was it. And the thing they can say additionally is find the length, find the angle, stuff like that. But the only thing you have to notice is it's the same triangle and it has been rotated. Sometimes they can flip it. So as in they can mirror the triangle. So this specific triangle, let's do it like this. This is what I mean with mirror. They do this with the triangle. Yes? And then you have to figure out another length. So the first thing you have to know is, okay, whoa, ML, where did ML go? Oh, ML is on this side, on the other triangle. So you have to try to figure out the other angles as well. Yes? That is the first step. The other step, delete, is they're going to place two triangles inside of each other, and for you to figure out the length of either one or both or some lengths. So let's get into that. Triangle. And then they do, for example, this. The teacher has done something like this. ABC. Easy numbers. That's 6. They ask you to find the length of one more. Okay. Here's 8. Try it nicely. Find the length of BD. BD. Sorry? No, BD. What I gave you was BA or AB. What's the first thing you notice?
It's in the middle.
Sorry?
It's in the middle.
What is in the middle? Yes?
Where BT is.
Mm-hmm. This is one triangle and
BT
is one triangle. Correct. So what do you have? You want to represent, it has to do with the congruency again. These two triangles have a specific factor differences. They're within each other. Both of them have the same angles. They're inside of each other. So this angle over here, or I put like this angle over here is exactly the same as that angle over there. This angle over here is the same as that angle over there. Yes? Same triangle, still 2.2, congruency, same triangles. This length is either smaller, in this case it's smaller, than this one. It has a specific factor that it's smaller of. For example, BDE, or let me say DE, is half the size of AC. So if I'm going to calculate BD, knowing that BA equals 8, and knowing that DE is half of AC, what do you think BD is going to be?
4.
How do you get to 4?
8 divided by 2.
So the answer to BD is 4. So what's the problem with congruency? That's 2.2. That's nothing else to 2.2. That's it. That is 2.2. Let's take an exercise from the book and you see exactly what we've done is exactly the same thing. The way it is written is differently, but everything else is exactly the same. Let's see. Page. No, I didn't grab the page. Exercise.
No, but what I had problem with was 2.3.
Oh, I took 2.1. 2.2. Oh, my apologies. Only 2.3.
Yeah.
Same thing. Same thing. Same thing. Wait, this is addition. I think I know what your problems were. The first exercises, 21, 22, you're probably talking about Z angles, cross section, F angles. Those you're having problems with. Everything up until 23 is what I've done here. Really, you see? 2 triangles. This is a smaller one. The same size as that. So if you see these 2 lengths, you add them together. You see, because this is one triangle. So If these two are the same, you look for the factor difference between one and the other, and then you can just divide or multiply the one that they want. It's nothing complicated, extremely easy. The Z, the X, and the F. So that you have problems with. Okay. Extremely easy. The angle there is the exact same angle on the inside of a Z. The thing is, you need to be able to see it within a shape. So if I draw a Z, the Z doesn't necessarily always have to be the same. See what I did? And I told you this length or this angle is 52 degrees. Find the angle of that one. And you should be able to see the Z shape in this specific or in these two triangles.
52 degrees.
Correct, because the Z shape says, it's the law of the Z shape states, this angle is exactly the same as that angle. And if you see, this is my Z shape. So this angle has to be exactly the same as that angle. Yes? X. It's like you already know this. Or you don't.
Not
Opposite angles. All right. I'm not sure if your book has it for a Z angle. I'll put this additional. These two lines, if I put an arrow like that, do you know what it means?
Yeah, that means they're the same.
They're the same? Mathematical term. What is the same?
That one is parallel to the other.
That's the word I wanted to. They're parallel of each other. Yes? Okay. So at times, you can think, oh wait, it looks like a Z. It all depends on the teacher, the equation, how strict they are, various factors. That sometimes they can give you, oh, it looks like a Z. It's no Z. That's not a Z. Why is it not a Z? Because these two lines have to be parallel of each other. Supposedly, you should be able, or you should find these two arrows within the shape. Supposedly. If you're doing it correctly, you should state it so I don't have to figure it out. Oh, I think it's a Z. Yes? I'll just throw it in there. Two triangles. There we go. They say this is not 180.
Okay, I found this on the web, for they say this is.
Oh. 70. And then they ask you, find the other angles. And you only know the inside of there is 70. Opposite angles state the angle over the top is the exact same angle you have over there, and the angle you have to your left is the exact same angle you have on your right. So if I tell you the purple dot is 70, you will tell me this angle equals
7.
correct. And now comes the difficult part. What is this angle? And how do I get to it? Most importantly, how do I get to it? You know, this angle? All right. There is something called a stretched line. A stretched line. A stretched line has a total of 180 degrees. This is a stretched line. And if I say this part is 70, what do you think is left for the other side? Stretched line. From here to there is 180. I have,
Minus 180.
sorry? 180 minus 70. Correct. And your answer becomes, and if that side is 110, what do you think the other side is?
110.
I thought you said you don't understand.
It's because I did it.
What else do we have? F angles. All right. F angles. Let's go get for F angles. F angles is the most tricky one, the trickiest one you can find. Let me draw some F angles. What else can I, how else? Like this. And the mirror version of these. All these are F. All these are F. And the mirrored version. So F is always the trickiest one to find. And the same with Z. In order for it to be an F,
It has to be parallel.
these two lines have to be parallel of each other, or else it's not an F. And the law or the rule of F states the angle inside the F here is the exact same angle down there. No difference. And if you notice correctly, 180. Don't forget. Most of the time, what do? They give you that angle to see if you figure out, oh, it's an F. So if you find the inside, you find that as well. So that's how they play the games in mathematics. So they give you a shape, and draw a weird shape. Normally, they should be given. You should see them, these arrows. And then they say, this degree is 32. Find that angle. The first thing you notice when you see this weird shape is, oh wait, that's an F. And I know the rules of angles of F. This angle is exactly the same as that angle. So the thing I need to find or calculate is that angle. As soon as I have this angle, I know that angle as well. So the question begs, what is this angle?
32.
Sorry?
32.
32? No.
180 minus 32.
Correct. 180. This is part of 180 and then the rest. So 180 minus 32, you get 148 degrees. And if this is 148 degrees,
That's 148.
that is also correct. 2.3 at your service. Let's make 1 or 2 exercises. I think these are too easy for you. I explained everything already. This is a good one. We'll do that after. Which exercise do you like? The difficult ones or the easy ones?
Easy one.
Easy ones, then we shall give you the difficult ones. Okay. Come on, dude. Fine, whatever. Exercise 29. Does it say angles? No, it doesn't say angles. Still congruency. There's no angles. Let's do 29. Doesn't matter. So, 29. Or did you already make it? Did you already make it?
No.
You can start. I'll try to draw it. When I went to middle high school, drawing was one of my most hated subjects.
Mine is my favorite.
Black. 20. ABC, A, B, C there, we have D here, E, 27, 18, 8, 21 and 2. 1, 2, 1, 2. E29. In figure 2.35, DE, you know what those two lines mean? Represent?
Parallels.
Correct. DE are parallel to BC. Calculate AB, BC, and BE. Round to 2 decimal places. AB, where's AB? Where's AB? BC, 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 and BE. Oh, BE here. Did you make them?
Sorry?
Did you make them? No, the exercise. 829.
I didn't make to.
Hmm?
I didn't make to.
Let's make it. So, the first thing I notice, it's an F. Why they have 1 and 2, I have no idea. Because there are no angles. It's 90, and that should also be 90. Anyway. When I look this specific triangle, AC represents, or AD represents an enlargement of the length AC. Meaning that AC is an enlargement, it's the same thing as AD. It's an enlargement of it. Right? Did I draw it correctly? That small thing is 18. Okay. If AD is 18, that means AC equals 18 and I add 8. So the length of AC is actually 26. So they give you AE. AE represents AB. So what is the factor difference between AC and AD? Meaning AD 18 has to be multiplied by a specific number to get to 26, or 26 has to be divided by a specific number to get to 18. You can do it in different ways. First way is doing it the cross.
Cross product.
The cross what?
Cross product.
Cross product, yes. Prijslees vermenigvuldigen. Cross product way. AC. I have to do it like this. 18 represents 26, and I'm going for AB, and this is the smaller one, like this. So, cross product, 26 times 27 divided by 18, and you get your answer. And the length should be 39. Oops. Mm-hmm. The other way of doing it is the one I normally use, the factor method. 18 multiplied by something is 26. I would like to know which factor. So in order to get to that answer, I did 26 divided by 18. This answer becomes 1.44. Yes, that is the factor it's being multiplied by. So if I want to know the length of AB, I need to multiply AE with 1.44. And if you do that, your answer is also 39. So 2 ways of getting to the answer. Most of the time I prefer to use this, because if I do the cross product, it's just taking me too long. If I use this, I only have to multiply or divide by 1.44. Because if I have 39, if this is 39, I only have to subtract from 27, and then I have this angle. Yes? And then they would like to know BC. How do I get to BC?
It's 20 plus D is parallel to BC.
20? No, it cannot be 20. It is an F angle. But F angle, I said, the angles are the same, not the length. The angles in an F angle are the same, not the length. The lengths are different. Yes? So, the same thing you did with AE and AB, the same thing you have to do with DE and BC. Either you do this or you multiply with 20. 20 multiplied with 1.44. So the length of BC or 29. To round off to a whole number, it's 29. Yes? Another one. $28. Like this. Like that. P, T, S, 20, Q, six, 8, 1, 2. Calculate QSPT and QT. So the first step, which length represents which length? Which length on one triangle represents the length of another triangle?
S, R, and
The SRN,
P,
AT,
P,
oh, PT, yes, RSPT. And then the length This is a trick question. It's not the same as 29. QR and PQ, correct. In an equation like this, the mistake you can make is you add these two together, thinking it's 28. But the thing is, this is a triangle and that is another triangle. So you cannot add the 8 and the 20 together, they're separate. So PQ is 20, which represents QR on the other one, which is 8. So you can either do the cross or find the factor difference. You choose which one, and then you tell me the answers to QS, PT, and QT. Sorry?
Why is PT 6?
PT is 15.
Why G is 6?
Congruency. RS represents. What did you do? But what did you do?
No, I didn't do anything because I really don't really know how to do it.
So the first step, remember, you have two triangles. Same with 29. You need to look for the side that represents the other side. And then you look for the factor, or you do the cross in order to find the other side. You remember? 20 on the larger triangle represents 8 on the smaller triangle. So PQ represents QR on the other triangle. PQ represents QR. So what is the factor difference between QR and PQ? Well, the factor difference is 20 divided by 8, which is 2.5.
I think it's because the cross product thing is messing me up because I'm not good at that, but the teacher said that we have to use it for the test.
Oh, you have to use that for the test.
Yeah, but the one
Alright.
I'm using right now is easier.
All right.
Because the cross product one, I don't know how to like where to put the numbers. It just looks like messing me up.
Okay, you have a cross. Always easy. PQ, QR. QR, PQ, okay. QR represents PQ. The one you have and the one it represents beneath, always. Yes, the one you have, the one it represents. Go back up. Which one do you have? RS has to represent what? PT. I'll change it color. PT. That's it. The one you have, the one it represents. And then you just fill it in. QR was 8, PQ was 20, RS was 6. So what does it represent? 20 times 6 divided by 8. Let's see, divided by 4, 30, 15. 15? All right. Your teacher can give me 1 point. Yes. So, 15. Now, do it with the rest. The rest. You still have. We only did PT. You have QT and QS. Now, QT and QS, if you look at that triangle, you cannot do what we just did. Why not?
Because there aren't any numbers that
Correct. There are no numbers at QS and no numbers at QT. So there's no doing any cross because there are no numbers. But how do I get to the answer?
can flip.
Pythagoras theorem.
Oh,
Pythagoras theorem. Right angle triangle, 8, 6.
yeah.
Bam, got to that answer. Or you have this and that. So you can do that. So it doesn't matter which one, you get to the same answer. So, Pythagoras theorem. You know Pythagoras theorem?
Yeah.
Okay. Let me know if I have the correct answer. If I'm not mistaken, the answer is 10. C equals 10. Sorry, QS equals 10. We're doing QS?
Yeah.
Do QS. Let's see if it equals 10.
theorem. You know the formula is like AB plus AC or whatever.
Does the teacher make you do it the exact same way she does it?
Yeah.
Okay. Let me try to remember. Uh-huh. If I'm not mistaken, you do something like this. You use a table? No? What do you use?
Definitely this one.
You just use the sides. So you say, for example, what is it? RQ squared plus RS squared. Yeah, that's what you use? Okay. PQ squared at PQ, oh no, sorry, it's RQ squared. RQ squared plus at RS squared equals QS squared. Like that. And then all you have to do is fill it in. RQ is 6 squared at, oh sorry, RQ is 8. RS is 6 squared, which equals QS squared. Wait, you're using a calculator for 8 squared? You may not use a calculator for 8.
No.
What is the definition of something squared?
Times itself.
Correct. So,
8 times 8
Equals?
64.
correct. When I was doing, so 6 squared?
Is 36.
Correct. Equals QS squared. You add 64 with 36 equals?
100.
Correct. Equals QS squared. All right. I would like to have QS, not QS squared. You already know something squared is defined as multiplied by itself. So I have
100 divided times 100 is.
wait, you have two numbers multiplied with each other, which are the same number, which is the same number, equals 100. What is that number? How do I get to that number? You take the squared root out of that number. So the number or the unknown number is the square root of the answer. And you already know the square root of 100. No. Correct. Yes? When I was doing my degree, I had a very difficult teacher. We had to do the entire thing without a calculator. And he stressed on us, calculator helps you find the answer. So for example, you need to take the square root of something, or 1.26 multiplied by 3.357, complicated stuff like that. But everything else, take that calculator and put it on the side. You can do it yourself. Easy numbers. So if you're using the calculator to add 20 with 30, we have a problem.
Okay, 20 with 30, obviously that's going to be 50.
No, I know. That's taking that's an example at the level you're at. If you need to take a calculator for 8 squared, we have a problem.
Just because I don't trust myself.
No, you have to trust yourself. The thing about mathematics, the first thing about mathematics, if you know this correctly, notice it may be in most science teachers, not all, it has to do with character. Most mathematics, that mathematics can be physics, chemistry, they have something in common with each other. They're very sure of themselves. 8 squared is 64. How do you know? Because I know. But how do you know? I know. Let me take the calculator. Is it correct? Yes, it's correct. Because I know it's correct. They have a certain thing about their character. If you noticed, maybe you noticed in their character, they're sure of themselves. It's like that. It's like that. Done. So in mathematics, the first thing you need to know, be sure of yourself. Zero doubt. And if it's wrong, yeah, whatever. Yes? In the exam, that's the same way you have to go about it. Square root of 80 is 64. That's the answer. Be sure of yourself. When you start doubting yourself, the chances are that you're not sure. Wait, what is the formula again? I think it's a squared minus. Oh, wait, what? Start doubting yourself. No, this is the formula. This is what it is. Done. And then you go for it. Yes? So, QS is 10. What is QT?
QS is the same as QT.
QS,
Not the same, but it's in a large.
it's in a large, correct. Correct. So how do we get to QT? Use the cross table. Here is the cross. You tell me, what do I need to fill? Left?
QS at the top,
QS.
or S.
You need two known angles. Two known. And the one you don't know is unknown. So that one stays empty. So these three have lengths. You can choose any. Which one represents which?
Q2 is also QS, or the other way around?
What, QT? Yes, yeah, you can use that one. That goes over here. QS represents QT. All right. Then you need on the left-hand side something that is already known. Two lengths that represent each other that are already known. Which lengths are already known?
QS.
Sorry?
QS.
Q?
Or QR.
QR and
S. R. S.
when you take QR, you need to take the length of the triangle it represents.
So PQ.
Correct. QR and PQ. So here you have QR and this is PQ. And now you fill it in. QR equals 8. PQ 20. QS 10. And then what do you need to do?
20 times 10.
Equals 20 times 10 equals
200.
divided by 8 equals
20?
if 20 times 10 equals 200, 200 divided by 8 cannot be 10.
Oh, wait, no.
It's super easy. 200 divided by 8.
I don't know.
Yes, you do.
I don't.
When you're counting money, you're getting to 2 guilders. How many? You need 8 of something 8 of the exact amount of coins to get the 2 guilders. Which coin is that? 8 exactly the same coins. You need 8 of them, and they form 2 guilders. Making mathematics easier. If the number is big, you make it smaller. Oh, 8, 200. Oh, wait, 25 cents. Yeah, I put 8, 25 cents, and that equals 2 guilders. Yeah, you connect the dots. Yes, you use your calculator as less as possible. If you take away the amount of time, let's say you have an hour for the test, you take the amount of time you use your calculator, you maybe saved maybe 15 minutes, because every time you're wasting time, because you're doing 3 times 5, no need, it's 15, you already know it. So if you go and you just lost that 10 seconds you pressed on the calculator. Yes, that's why you focus more on not using a calculator, not using a calculator, not using it. So you can be quicker and have more time in the test. Another one. You can do that. 27. Like that. Like this. Like that. D. H. G. 2.2. 1.4, 1, 2, oh wait. It's F. H, G. Calculate HG using the cross. Let's go at it. You know from advanced, HG goes here, because that's the one you want. HG goes there, that's the one you want. Which side represents HG?
D.
Correct, so that goes on top of it. Bam, bam, bam. Now I need two lengths that represent each other. Which two?
F and
Sorry?
E, F and F, E.
Correct. So you have EF and you have FH. All there's left to do is fill it in and then calculate. Down. EF is 1.4, FH 4.2, DE 2.2. Now you are allowed to use your calculator. And your answer becomes
6.6.
correct. And now you have to do FG. FG. So, wait, FG. Oh yeah, yes, FG. So, FG goes bottom right, because that's the one you need, FG. Which length represents FG?
DF.
DF, that goes on top, bam, bam. Now, two lengths on the left side that you have that represent each other. You can take the ones you already have.
D, E, N, G.
Which ones?
D, E, N, H.
D, E, N?
H, G.
Yes, you can use that as well. Is it D, E, and
H.
H, G? Next step, fill it in. DE was 2.2, GH was 6.6, DF 2.6, correct. Wow. I thought you had problems with 2.3.
That's because I
The last one is DG. DG. That's an easy one. What do you have to do to get to DG?
Pythagoras?
I say no, you tell me why. Why can I not use Pythagoras? Look closely at the triangles. I can only use Pythagoras theorem in a certain triangle.
On a right angle triangle?
Now looking at these triangles, are they right angled? No? You're asking me or you're telling me?
I'm telling
Why are they not a right angle triangle? What makes a triangle a right angle triangle?
One.
One of the sides, if you look here, has a what angle?
Right angle.
Which is how many degrees?
90 degrees.
Correct, this. And 99% of the time, they state it, as in they put this particular, say, call it chair, in that corner. So you know in advance, oh, that's a right angle. Does these two triangles, any of them have that chair? No. So you know in advance, oh, that is not a right angle triangle, meaning I cannot use Pythagoras theorem. So, how do I get to DG?
The cross.
You can do that, or is it DG? Yeah, DG. Or you can do it a faster way. What is the length of DF?
2.6.
What is the length of FG?
4.2.
So what do you think you have to do?
Plus.
You add them together. So DG is 2.6 at, is it 7.8? 7.8. So your answer becomes
6.8.
DF.
Where'd you get 7.8? Oh, DF.
DF, yes. Well, what did you do?
No, but
DF is 2.6.
didn't you say you had to add DF
And
and
FG.
FH?
No, FG.
But we don't have FG.
Yes.
Do we? Oh, wait.
Yes. We just calculated 7.8.
Because I thought you said FH.
Oh. FG. DF and FG.
Mm, 10 point something. 10.5.
You have to start practicing by memorizing or doing stuff without the calculator as much as possible. Why? When you get to form 4, or if you go to Vario, you only pick it up if you need it, because you have no time. You only pick it up if you need it. Everything else is like this, because there is no time. They expect for you, oh, if you do 8 squared, they already know you know 8 squared, so I'm not gonna give you 2 minutes to calculate 8 squared. It's 2 seconds, it's 64. Yes? So practice not using your calculator as much as possible, and only use the when you need to calculate complicated things. The square root of 1.26. Yes, 1.3456 multiplied by 6.5359, something like that. Everything else that is easy, don't use it.